It was a snowy and very cold day, but we are here in D1, me and Dylan. We're going to look at the assignment Linux TCP/IP utilities. We want to make sure that your virtual machine is on what's called a bridged adapter, meaning your computer is connected to your local network. If we go to Machine and Settings, this should be set to bridged adapter. If it isn't, make that change. And typically Linux doesn't get a new address as easily as Windows does in VirtualBox. So you may want to restart your Linux machine. Now, we're going to start out using a GUI TCP/IP utility. Right up here, we have our network cable. And in VirtualBox, it's always an Ethernet connection, whether your computer is connected by wireless or not. Doesn't matter, because it's virtualized. I right-clicked on this little guy. We have connection information. So ETH0, there's the hardware address of my VirtualBox. I have 1,000 megabits connection because that's how fast my Ethernet adapter is. So it's a gigabit Ethernet adapter. Here's my IP address. There's my subnet mask. Default route is our gateway out of the network. And, oh, actually, this server is not running right now. Okay, so that's the one I'm reinstalling in the back room because when I upgraded to Windows Server 2025, I had trouble, so I'm starting it over again. However, we have our secondary DNS that's up and running just fine. LO is your loopback address. The loopback address is for testing. Now, if we right-click on this, we're going to do something extra special. Go to Edit Connections. We have our wired connection. We're going to go to the little gear, which means Edit, in this case, or Settings. There's our Ethernet. It's just showing the Ethernet. What we want to do is go to, and remember Ethernet's on layer 2. We're going to go to IP version 6. Well, it's automatic. This is where we could set manual if we wished. The DHCP works fine for what we're doing. All right, we're going to go ahead and cancel. We've taken a look at one of the GUI utilities built into Kali Linux. Now, to really do something, we have to get to the terminal. As Dylan was saying earlier, at first the terminal is a bit scary, but when you get used to it, it starts making sense, and that's where all the fun stuff is. Right up here, we have our terminal button, and that brings up the terminal emulator. I have this set so the fonts are bigger so you can see things better. One of our #1 troubleshooting commands in all operating systems is ping, Packet Internet Groper. It uses the, I forgot what the name of it is. It uses the ICMP protocol, which is a testing protocol, to send packets from your machine to another machine to see if there's a connection. And if it gets a reply, it measures how fast it takes in milliseconds. So if we ping google.com, well, it should work. Oh, there it goes, it's pinging. If it fails, we're gonna have to do a little troubleshooting. Oh, there it goes.
That's mine. It says mine's network is disconnected.
Oh, well, let's stop for a second. Mine just took a bit to work. But as you can see, there is a difference between ping in Linux and ping in Windows. Well, the ping in Linux just keeps going forever. This one also resolves the address of whatever router we're pinging. And there's the IP address of google.com. We had 42 to 50 milliseconds, which isn't too bad. So let's pause and see what's going on with Dylan. All right, we're all fixed up. All right, the next one. We're going to explore the traceroute command. Now, if you remember the traceroute command on Windows, it's very slow and pokey. The traceroute command in Linux is actually the word traceroute. And we'll do our friend Mr. Google again and see what happens. Yeah, it's tracing the route. Yeah, I thought I remembered it was faster. Oh, it's going pretty good. So the first hop goes to your router of your network, and that's the router or gateway to my network. The next hop is the outside IP address, or I'm sorry, it's not the outside IP address. It's the router's default gateway on the public internet. And then it goes to the next hop, then it goes to the next hop, and it goes to the next hop, and eventually it's going to get to Google at the other end. And sometimes it will actually resolve things as a domain name, sometimes it won't. Sometimes you'll get a response and sometimes you won't. Just depends. This relies on the routers being configured to return a ping command. Not all routers are configured like that. Oh, here's one right here. Number 10 has ****. Well, it's not configured to return anything. But that's fine. That's a security thing, so people can't ping and find out. I will pause the recording for a second as this moves itself along. ND1 10.0.1.10 is our primary server. This is a secondary server, 10.0.1.11. However, since that server's down right now and I'm reinstalling it, notice that our DNS is not going as quickly as it could. So I'm thinking that maybe I should set this as the first one instead of setting it as the second one, then it's not going to fail over. And there it is. See, 10.10.10 is set as the first DNS in the room. Well, it's not the first DNS anymore. Let's move that up and apply it so that from this point on, until this other one comes online, and I may just leave it that way. There's nothing wrong with this one doing DNS resolution. It may or may not speed things up, but at least it's a server that exists. That's a good thing. All right, that'll update things as we go. Now on Windows, we want to do that next just to see how pokey it is. On Windows, you would use TRACERT, google.com. That is a holdover from the old DOS days where we had 8.3 file names. We had 8-character limit, and you could have a 3-character extension. Yeah, I think this is a little bit slower. Maybe not much. It's not moving real fast. Well, it is going much slower. But eventually, it should get to the end. You may want to do some other work while you're waiting for this to finish. In fact, I think I'm going to go to the next part. And we're going to take a look at Linux manuals. Well, Linux manuals, man, is kind of like the help system for Linux. So if we do man, which is means manual file, and we do trace route, there, look at all these things. It tells us what trace route is. It gives us all kinds of things that we could use. Yeah, there's lots of arguments that we could change. If you want to go down, you can press the space bar and it goes through all kinds of stuff. TCP trace route. Oh yeah, there's stuff in here that, yep, once you're, you don't have to go all the way through it, but Q will quit. So now we know about the manual file. Well, that's more information than I needed. There's another way to get help in Linux. We're going to do trace route -- help. Some command line arguments will have 1 --, some will have 2. No. Well, how is this different from the last one? Well, you have to scroll up to see it. All it gives, it doesn't give any verbal explanations. It gives all the arguments and what they're supposed to do. So it's not as much information as you would get from the manual file. MTR is kind of a path ping command. Let's try MTR google.com and see what we get there. Uh-oh, what do we do now? Well, step 18 says, if it says it's not been installed, you do sudo apt update. And it's suggesting what you can do, sudo apt install mtr. But before you install any packages from the apt package manager, always get the latest current information from the mothership in the cloud to make sure that your local computer knows the latest information about the packages. So you get the latest versions. There. I am not going to update 2073 packages. You don't need to. All we are doing is apt install. Oh, here I have mtrgoo. Well, the directions said mtr. So let's try just mtr. Oh, there it goes. It's installing. So this must have been at a time when you had to do mtrgoo. I don't know. We'll find out. Update my directions here. We're connecting, we're getting, we're fetching, we're reading our database. I got all kinds of things going on here. Today is the 19th. Oh my gosh. It's the 19th already. Next week is week 7. We're getting close to spring break. It doesn't feel like spring today because it's very cold. It was minus 23 at my house. All right, rather than typing things in again, I am going to cursor up, go through the command history, and do an mtr google.com, see if it works. Ooh, look at there. It's got a little graphical interface. Don't you like that? And it runs a lot quicker. Look at that. Did the same trace. It's gone all the way to Denver. It's hard to believe we have to go through all these people to get to Denver. Well, actually, it's going through Chicago. Our internet signal here at the college goes to Lincoln, actually, before it goes out on the internet. And then from there, apparently it goes to Chicago, then it goes to Denver. So we're kind of taking a round robin trip to get there. There we go. That's kind of a fun little guy, isn't it? All right, so now we know MTR works really fast. It's a very nice little program. All right, so now we are going to look at the different configurations for Linux in the command line. We looked at the GUI and there was all kinds of information in one spot. Well, to find out all your IP addressing information, I don't know a utility that does it in one thing, but I know this works for the separate things. We want to find out what are our DNS servers. Cat is a command that stands for concatenate. Its purpose is to very quickly read text files. Since every configuration in Linux is stored with a text file, there's lots of programs that read and write text files. There. So right now, my name server is 10.0.1.10. That's eventually going to change for everybody and reverse those. So 11 is the first DNS server. So now we know our DNS servers, which that matches what you saw earlier for my DHCP server. Well, what's next? IPR shows my routing. The only routing I have set up on this is if the packet doesn't match my network address of 10.0.1, I send it to the gateway. That's the routing that's set up on, that's the basic routing that's set up on almost all client devices, because you really don't do routing for other devices. And the only route we need to know about as a client is it's either on the network or it's not. So it determines that by /24 means 255, 255, 255.0, which means this is my network address here. At home, my network address is 192.168.9, and my gateway is 1. Well, we got more information. This next command is one we've used before, IP space A. That gives us our IP address. /24 is our subnet mask. And broadcast, 255 is always the broadcast, like ARP and some other protocols use broadcast. If we are just connecting to a network and we need to find a DHCP server, that's a broadcast.
I know, I was thinking about Hypothetically, if you could,
All right, moving on, we're going to install a secure socket or a secure shell server. So remote access to Linux machines is almost always done in the terminal commands.
No, that was mine. That was
So
my,
whoops, that's the wrong one. Let me make sure my shared clipboard is on. Well, it was disabled. Once the shared clipboard is enabled, then I can use Shift Insert to paste this in. I don't have to type it in again. So I'm going to install the Open SSH server. There we go. We say yes. Oh, it says it's upgrading, so it's apparently already installed. So it's probably enabled, who knows, but we'll go ahead and do the other stuff anyway. And then we will remote into our Kali Linux server from our desktop. The next step, enable the service. There. Now the service is running. We need to start it. Systemctl is the service manager for Linux. It allows us to stop, start, enable, disable services. Services are background programs that we don't see running, but provide services for us. In this case, remote secure socket, remote secure shell access. All right, there we go. One of the things that we need to know is our IP address. Well, there's my IP address, 10.0.1.104. Next step, we need PuTTY. PuTTY hasn't been updated in about 50 million years, but it's still one of the go-to programs for doing secure socket. There's a lot more fancier ones, but this is very simple. There it is, download PuTTY. It's an SSH client. We'll download that little guy. Oh, I guess we're not going to download it yet. I want the, there we go. I just need this guy, 64-bit x86. This is a portable file, meaning I don't have to install anything. In fact, I have a copy of this on my USB drive, so I don't have to download it all the time. Going to save it. And then run it. As you can see, it is a very simple little program. The connection type is SSH. The port is 22. So we are going to make a connection on port 22 to our Linux computer because it's listening on port 22. 10.0.1. I think it was 104. Cross your fingers, see if we get lucky. Ooh, look at that. That's what we're supposed to have. We do want to accept. SSH is encrypted by certificates. Well, these are local private certificates. There's our key fingerprint. And we do have a guarantee that the server is the computer we think it is because it is our server. We accept. And I'm going to log in as me, user. There, I can now be anywhere in the world. And I could do anything I wanted to this server because I'm logged in with Red Access and I don't have to be in the same physical room. Although this is on my same computer, it doesn't matter. However, if this was somewhere else, I would need some sort of access to that network.
I need help.
We're in PuTTY, everything here, we're running just like we're on the regular computer. So we're going to do sudo TCP dump. What does that do? Let's find out. It's not showing us a whole bunch, is it? Now let's Control C to exit. Oh, there it goes. It's listening on ETH0. It kind of looks like a Wireshark thing, doesn't it? There's a connection to Zoom. That's me talking and being recorded. So TCP dump is like a little command line packet sniffer. Well, let's control C to stop that. What's our next one? Ooh, I think Nmap's already installed. There was a time when Nmap was not installed in Cali, and then it was installed again. I don't know, they can't seem to make up their mind. So we don't need to install it. We're gonna do sudo nmap. And this is going to be the address of our network. Oops, my numlock is not on. Where's my numlock? There it is. Oh my goodness. Let's try that again. Boy, it does not like the numlock in this case. 10, okay, it's typing there. 0.1.0/24. There, we're scanning the network from our Kali Linux machine. Oh, failed to resolve sudo. Oh, somebody typed in his command wrong. I had an extra sudo in there. I had an extra nmap in there. There. That'll work better. Now it should come up with something at some point. Well, I know it's going to come up with something. I'm going to control C to stop it. We have a couple more commands. NS lookup is a troubleshooting command we used this week. I think we used it this week or last week in our Windows Server class. NS lookup is a reverse DNS lookup. Uh-oh, host is unreachable. Oh, it's still trying to talk to 10.10.1.10. Well, things have not changed yet in my network, so eventually it'll be 10.0.1.11. But it did resolve it. It didn't, it said non-authoritative answer because I am not responsible for google.com. My servers in the back of the room are responsible for anything in the room. So if I do NS lookup, what's the name of my server? ADS2, that's the one that's online. My DNS servers are authoritative, except 10 is not running right now. The reason it's doing pound 53 is DNS runs on port 53. There. See, it doesn't say anything about not being authoritative. That automatically means that it is authoritative. So my server in the back of the room is authoritative for this domain. It knows what's going on. Dig, like digging a hole. Not really like digging a hole. Yeah, eventually everything will sort out as we get new IP addresses. Whoa, look at all that stuff it came up with. Way more than anybody wanted to see, didn't it? It says we're on a Debian. It says it got an answer. It gives us all kinds of codes and things. It does end up showing the DNS server that is resolving it for us. There's google.com at this IP address, so we did get that. It says that it's an A record, which means it's a host record, which is a lot of what we'll deal with. Our Kali Linux has a host record. Most things have a host record. We have some more. Let me clear out this guy. And then we're going to do ARP. ARP is our protocol that resolves layer 2 MAC addresses to IP addresses. So right now, 10.0.1.108 has that hardware address. And so I don't know if we're finding everybody or we're just taking a long time listing the cache. But these are all the people that this computer knows about. So in order to communicate directly with this layer 2 MAC address, we have to resolve this IP address to that MAC address because we can't like ping that MAC address directly. What our operating system can do is communicate with an IP address, but we need something that translates so that we can actually get to the hardware address because that's where the local communication actually takes place. And it looks like the ARP command is like ARPing everybody in the room. Kind of like a little dog, it's like ARP, 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 ARP. Okay, well, that's enough of that. Control C will break most command line things in Linux. And with this, we have an IP neighbor command. Oh. So who is my neighbor? Ooh, look at there. There's all my neighbors. They're all part of my network. They're all in my network. Look at there. All these IP addresses. Says they're stale. I don't know why they say they're stale. There's a delay. Stale means they're not up to date. Well, let's see. That's IP version 4. We're going to do -6, which means IP version 6, which we haven't dealt much at all. There. This whole big long thing is an IP version 6 address. Whew. Yeah, I'm going to stick with, I'm not going to need to know this before I retire. So you will probably before you retire have to know this, but at this point, we still primarily deal with IP version 6 addresses. Eventually things will transition, but it's been transitioning for, I don't know, IP version 6 was put out 20 years ago. So it might be a while. That ends our exploration of Linux TCP/IP utilities.